Good morning, everyone, or afternoon, depending on what time zone you're in. My name is Jeanne Montblanc. With me is my co-coordinator, Corey Gooker, and on behalf of the Great Basin Fire Science Exchange and our partners, I would like to welcome you to this webinar and discussion titled Prioritizing Woody Fuel and Restoration Treatments in Sagebrush and Pinyon-juniper Ecosystems During an Era of Vegetation Change, Spatial Data and Management Guidelines, presented by Jeanne Chambers and Sofia Koutzoukis with the USDA Forest Service. Before I introduce our presenters, I will go over some webinar details. We're using Zoom Meeting as our platform with attendees' mics and cameras off. We will use the chat for questions, so please type in your questions at any time, and I will field them during Q&A and discussion after the presentation. Now, I'd like to welcome our presenters. Jeanne Chambers is an Emeritus Senior Scientist with the USDA Forest Service Rocky Mountain Research Station in Reno. She has lived and worked in the Great Basin her whole life with a prolific career focusing on developing ideas like ecological resilience and resistance for treatment prioritization, tools like the Science Framework for Conservation and Restoration of the Sagebrush Biome, and collaborative groups, including this Great Basin Fire Science Exchange, to help land managers find the best methods to conserve sagebrush steppe ecosystems. Sofia Koutzoukis is a postdoctoral researcher with the USDA Forest Service Missoula Fire Sciences Laboratory. Her work focuses on understanding vegetation community change, fire behavior, and management options in order to prioritize fuel treatments and restoration activities. Thank you so much, Jeanne and Sofia, for being here and presenting your research and recent work on the Elko Front with us today.
Thank you, Jeanne, and thank you for that nice invitation.
All right, I'll let you take it away. I'm seeing the slides with notes.
I am not, which is, let's see, let me try sharing the screen one more time.
Okay. We're still seeing the slides with notes.
I am seeing lots of different options for sharing here. Apologize for this.
No worries.
All right, let me do this.
Yay, looks great to us.
All right, thank you for your patience. So today, as Janie mentioned, we're talking about prioritizing woody fuel and restoration treatments in sagebrush and pinyon-juniper ecosystems during an era of fairly rapid vegetation change. We're going to be focusing in on the spatial data and management guidelines that we've recently developed. I'd like to start out by acknowledging the working groups that have helped us develop this, the Joint Fire Sciences Program Group, as well as the Sagebrush Steppe Treatment Evaluation Project. I'd like to acknowledge as well the Humboldt-Toiyabe National Forest, especially the Elko Working Group. Now, today, I'm going to start out by talking about the rationale for Forest Service high-priority landscapes, the characteristics of the Elko Front landscape, and its management objectives. I'm then going to tell you about the spatial data we've developed for prioritizing woody fuel and restoration treatments. Next, Sofia is going to jump in, and she's going to talk about her work on the Elko Front. This includes more detailed characterization of the vegetation associations and wildfire risk, and includes an assessment of the locations and extent of vegetation change. We're going to conclude with how our work on high-priority landscapes has helped us to expand our guidelines for prioritizing management. Now, as many of you probably know, the USDA Forest Service recently developed a wildfire crisis strategy as well as priority landscapes in response to the increasing extent and severity of wildfires we've seen in recent decades. These include four major objectives: The first is to mitigate wildfire exposure and impacts to infrastructure and our local communities. The second is to help those local communities become more fire adapted. The third is to focus in on protecting our high-value Forest Service resources. And then the fourth is really to increase collaboration with the Department of Interior agencies, the states, tribes, and local communities. Now, the Great Basin actually has several different high-priority landscapes. These are the Boise Front in Idaho. They are the Wasatch Front, as well as Pine Valley in Utah, and then Elko, Winnemucca, and the Sierra Front in Nevada. To show you the relevance of these different areas, in 2025, just last year, the Cottonwood Peak fire just north of Elko burned over 132,000 acres, and the Forsyth fire down in the Pine Valley high-priority landscape burned almost 16,000 acres. It consumed 14 homes, and it cost $35.7 million. Now, in the Elko Front itself, fire hazard is classified as high or very high across almost 81% of the landscape. The Elko Front is a high-value area. It surrounds numerous rural communities, including the town of Elko, of course. It has the Upper Humboldt watershed. It's a major source of drinking and irrigation water for over 60,000 people, and it also has some major transmission lines. The recreational values and infrastructure support over 500,000 visitors a year. The map on the right shows you the Elko Front. It encompasses 1.4 million acres. 340,000 of that is National Forest Systems land, and it's shown in dark green in the center there. The other ownerships are, of course, BLM, private, state, as well as tribal. Now, the objectives for the Elko Front are really similar to those that we have for most of our Great Basin sagebrush ecosystems. The first of these is to reduce wildfire risk. This includes mechanical treatments and prescribed fire to decrease those woody fuels. The emphasis here is primarily on encroachment of pinyon and juniper into our sagebrush ecosystems. It also includes targeted grazing to reduce fine fuels that are increasing as a result of our invasive annual grasses and forbs, and it includes fuel breaks as well to control fire spread, especially in our warmer and drier areas. The second major objective is to improve native vegetation, to increase the resilience to disturbances and resistance to invasive annual grasses. This includes controlling non-native annuals and noxious weeds, as well as restoring sagebrush habitat. The last major objective is to improve road networks, to really improve suppression effectiveness, and to ensure firefighter safety. Now, to help prioritize the locations and types of woody fuel treatments so that they will have the greatest benefits in terms of reducing fire risk and improving vegetation, we developed spatial data sets and maps. There are 5 primary data layers. These include indicators of ecological resilience to wildfire and management treatments, as well as of resistance to those non-native invasive annual grasses. It also includes the dominant sagebrush associations. Surprisingly, these had never been mapped for the Great Basin before. It includes areas in which we're seeing pinyon and juniper encroachment into our sagebrush types. And then it also includes our persistent or old growth woodlands, which we increasingly recognize as high-value resources. We combined all 5 of these data layers into treatment response groups. These are vegetation associations that differ in resilience and resistance, and also in their responses to fuel treatments. And you'll be hearing more about these as we go along. Now, ecological resilience and invasion resistance concepts really underpin our Great Basin ecosystem responses to disturbance and management actions. So let's start with a brief review. Because our sagebrush associations occur over strong environmental gradients, they differ in productivity and fuels as well as in resistance and resilience. They range from our warm, dry Wyoming sage at our lower elevations to cold, moist mountain big sage, mountain brush communities at our upper elevations. The primary threats, as we know, at our low to mid elevations are invasion of annual forbs and grasses and the development of grass fire cycles, and at mid elevations, encroachment of those pinyon and juniper species into our sagebrush systems. Now, this figure shows that ecological resilience increases across the environmental gradients. As the graph shows, resilience increases over elevation, but is modified by aspect in soils. There's a close relationship between our dominant sagebrush types, soil temperature and moisture regimes, and relative resilience. Our high elevation systems have greater resilience because they receive more precipitation and have higher productivity. Because they have higher fuel loads, they burn more frequently in the past, and they have more fire-tolerant species. Changes in vegetation, as indicated by those downward arrows and the red line, can significantly reduce resilience. And we know this because if that resilience is reduced, we see large changes in not only composition, but also a decrease in recovery. Now, this graph shows that resistance to cheatgrass also increases over these elevation gradients. This is because, first, climate suitability is greatest in our Wyoming big sagebrush types, and these are, of course, characterized by those warm and dry mesic soils, and it's lowest in our mountain brush types with cold and moist, those crike xeric soils. Second, greater resource availability and productivity as soil moisture increases across those elevation gradients results in higher competition with the invasive annuals. Disturbances that increase resource availability and reduce competition decrease resistance to invasive annuals. And I want to emphasize that particularly important here are our perennial native grasses and forbs. Our prior work in these systems shows that if you go in and you remove the perennial grasses and forbs, you get a 2 to 3-fold increase in cheatgrass biomass and seed production. However, if you go in and burn the area, you get a 3-fold increase. And then if you go in and you remove those perennial native grasses and you burn the area, you get a 10 to 30-fold increase. Many other follow-up studies have demonstrated this as well. Now, we recently developed new indicators of resilience and resistance. The indicators are intended for use in understanding the recovery potential of ecosystems and landscape scale prioritization. There's been some confusion lately, and I wanted to clarify that they are not meant for fine-scale analysis of plant communities. Now, to develop our R&R indicators, we assembled a large database of vegetation sampling plots from the BLM Assessment, Inventory, and Monitoring Database, our Forest Inventory and Analysis Database, as well as our long-term sagebrush step evaluation treatment plots. To ensure that our indicators would be applicable to landscape scales and that we could use them in climate models, we derived multiple climate variables for each plot using hydrologic models. We then assigned our R&R categories using NRCS soil survey information and ecological site descriptions, and we did this to ensure that they would be applicable to management. We then used random forest models to develop our product, as you see in the maps on the left. And if you look, you can see that for both resilience and resistance, low is indicated by red, moderately low by orange, moderate by that light blue, and then high to moderately high by that dark blue. Like many of our systems in the Great Basin, we see that because conditions are relatively warm and dry, we have a high percentage of low to moderately low. We have to remember that a full 30% of the Great Basin is characterized by salt desert shrub ecosystems. Now, this area shows the Elko Front project area. Again, as in much of the Great Basin, our forests, which support mountain big sage and mountain brush, are cooler and moister and have higher R&R. And this is in contrast to our lower elevation BLM private lands, which tend to be warmer and drier and support Wyoming big sage. Now, although the spatial coverage of all big sagebrushes had been developed, the dominant associations had never been mapped, as I indicated. Because these associations determine the types of treatments and treatment outcomes, we thought mapping them was essential. To derive our sagebrush associations, we used the Landfire Reference Database. Essentially, what we did was to go in and identify the dominant species for the combination of existing vegetation type, biophysical setting, and landfire zone in Landfire, and then we grouped them into the appropriate vegetation associations. The map on the left shows you the distribution of our sagebrush associations. Our Wyoming Basin sagebrush, which is categorized in Landfire, comprises 19%. Wyoming big sage, shown there in the gold, is 21%. Mountain big sage in the dark green is 13%. And then our other sagebrushes, basin big, mixed low, black sage, and low sage, comprise relatively smaller areas, basically 2 to 9%. Now, this shows you the dominant sagebrush associations for the Elko Front project area. And as I suggested earlier, the forests, and hopefully you can see that outline, are comprised primarily of those mountain big sage and mountain big sage mountain brush communities. If we look a little farther to the northeast, we see that that is primarily Wyoming and basin big sagebrush. Down to the south and over to the east, we see that we pick up quite a bit of low sagebrush. These areas tend to have shallower soils, and they also tend to be calcareous. Now, we mapped our pinyon and juniper cover using the rangeland analysis platform database. And to start out with some definitions, we defined encroached shrublands as areas where pinyon and juniper trees were establishing into sites that were historically characterized by our shrubland ecological types. Most trees in these areas established after European and Anglo-American settlement in the mid to late 1800s. We defined our persistent or old growth woodlands as historical, tree-dominated ecological types where site conditions, both soils and climate, as well as disturbance regimes, are inherently favorable for pinyon and/or juniper. Now, when we assigned our tree encroachment phases, we considered the productivity of the different sagebrush associations. For phase 1, that earliest successional stage, we assigned less than 10% tree cover to all of the different associations. For phase 2, we assigned 10 to 20% cover for our low and black sage, which have relatively low productivity, and then 10 to 30% cover for those big sage associations that have higher productivity. For phase 3, we assigned greater than 20% cover for low and black sage, but greater than 30% cover for all of our big sage brushes. We identified our persistent woodlands using the biophysical setting in Landfire. And to give you the percentages of what each of these are comprised of, and if you look at that map on the left, what we see here is that within the entire Great Basin, sagebrush without pinyon and juniper comprises 48.3% of the landscape. Phase 1 in gold, 34.2%. Phase 2, that light blue, 5.6. Phase 3, the next darkest blue, 4.6. And then our persistent woodlands in dark blue are 7.3%. This shows you the pinyon and juniper encroached areas, as well as our persistent woodlands for the Elko Front project area. And you can see the large amount of phase 1, that gold, scattered across most of the area. Then you can also see the phase 1 and phase 2 kind of at the lower elevations of some of our hill areas, if you will, in the area. And one thing I did want to point out is the extent of the persistent woodlands, that dark blue. They are basically on the east face of the rubies, as well as they are on the tops of a lot of our lower lying surrounding areas. Those basically ridge tops or those steep slopes with shallow soils. Now, once we had developed all of our spatial layers, we were ready to develop the treatment response groups. What we did here was to use information on long-term treatment effects from our literature review, our work on R&R indicators, and new fire behavior modeling that was based on the sagebrush treatment evaluation project data that was developed by the Lisa Ellsworth lab and her students. We basically used all 5 of our spatial layers to develop the TRGs. Now, we assigned those potential treatments using 3 different criteria. The first of these was durability. We wanted the treatments to have or result in a longer-term decrease in fire risk. The treatments should have been resilient in that they resulted in an increase in perennial herbs or sagebrush establishment, and finally, resistance. The treatments needed to have low initial cover of invasive annual grasses and forbs and little to no increase following treatment. Now, the different woody fuel treatments we considered were prescribed fire and several different mechanical treatments. Mowing for our big sagebrush types, and then mastication, cut and pile burn, and cut and remove for the areas that were exhibiting encroachment from pinyon and juniper. The spreadsheet on the right illustrates the assignment of treatments to the treatment response groups. For the big sagebrush associations, assignments were based on the dominant association and its environmental characteristics. As you can see, these related directly to the R&R categories that we had already assigned. Fuel treatments were constrained to areas with the highest probability of meeting our treatment criteria. If we look first at prescribed fire, these were restricted to those relatively cool to cold and moist big sagebrush types that had moderate to high resilience and high to moderately low resilience. In terms of mechanical treatments, and here we're talking about mowing, those were targeting cool to warm and drier big sagebrush types with moderate to moderately low resilience and resistance. Of course, mechanical treatments could be used anywhere prescribed fire was assigned as well. We assigned no treatment to our warm and dry Wyoming Basin big sagebrush types. These areas, of course, have our lowest resilience and resistance. As many of the managers have already realized, what we're seeing is if we do go in and treat these areas, we have fairly rapid conversion to annual grasses and forbs and/or low recovery. Consequently, fuel breaks are going to be the most appropriate treatment in most cases to protect these high-risk systems. Now, this shows the treatment response groups for our sagebrush associations with pinyon and juniper encroachment. Fuel treatments were again constrained to those areas with the highest probability of meeting our treatment criteria. We focused on phases, successional stages, if you will, 1 and 2 for both prescribed fire and mechanical treatments. This was because phases 1 and 2 typically have higher recovery potential, and there's also greater operational feasibility in terms of executing the treatments. If we look first at prescribed fire, we see that this is similar to our big sagebrush systems. We assigned it only to those relatively cool to cold and moist big sagebrush types with moderate to high productivity and resilience and resistance. These, of course, could also be mechanical treatments. In terms of mechanical treatments, we assign those to big sagebrush associations with moderate to moderately low resilience and resistance. And we also assigned them to less productive, low and black sagebrush with relatively high to moderately low resilience and resistance. When we developed these, we assigned no treatment to all sagebrush types with low resilience or resistance, to phase 3, and also to our persistent woodlands. But stay tuned to see how we've modified that. Now, when we put this all together, we found that the total area available for woody fuel treatments was a little over 18% of the Great Basin. The relatively low number was because of the high amount of low resilience and resistance areas, 44%, and the fact that almost 30% of the Great Basin is not sagebrush. As I already pointed out, it's salt desert shrub. The potential for prescribed fire is shown here in red, and it was 14.2%. But remember that these areas can also be treated with mechanical treatments. Of this area, areas that were encroached by pinyon and juniper were 8.8%. The potential for mechanical treatments, that area in blue, was 4.2%, and this was restricted to PJ removal. And I want to point out again that our persistent woodlands in this area, areas that we want to be very careful about how we treat them, are 7%. Now, this shows you the Elko project area and the fuel treatments. As you might expect, the Forest Service area is primarily assigned to prescribed fire, which again can also be mechanical. The areas essentially to the northwest that are Wyoming big sagebrush are not really assigned treatments. And then when we get into some of our lower lying ranges, we see that we've assigned mechanical treatments to those moderately low areas. And these are in the lightest blues. The persistent woodlands, again, here are in dark brown. Now, I've provided a description of high priority landscapes and our landscape data layers, as well as our treatment response groups. Now, Sofia is going to explain her finer scale work on understanding ongoing vegetation change on the Elko Front. I'm going to let Sofia start her own PowerPoint here.
Sophia, we can see with the slides on this side, and you're muted.
It gave me an option to unmute myself. I would like that.
Okay.
Can you see it? Is it big now or is, okay, got it. Awesome.
Yay, perfect. Thank you.
Okay, thank you so much. You think that after years of doing Zoom, okay.
No
Okay,
worries,
cool.
it changes all the time.
Oh my gosh, right?
Yeah.
Going from laptop to laptop.
Yeah.
Okay, cool. Thanks, Jeanne. So I'm going to take over and talk about more focus work that we did applying this to the Elko Front. The Elko Front was a perfect setting to ask about changing vegetation cover and how that can inform field treatment and vegetation management types and placement. So to do that, we asked 3 questions. What types of vegetation change are occurring in the different vegetation associations? How are initial vegetation conditions and climate drivers influencing those changes? And how can we use this information to prioritize management? So to answer our questions for the Elko Front, we built on the analyses of treatment response groups, as well as all of the data that Jeanne had previously described. But before we jump into the analysis, I want to go over the additional data sources that we used for the Elko Front. These are all raster and vector data sets that are all except one are publicly available and provide wall-to-wall CONUS coverage. So ideally, this workflow is generalizable to other shrublands. So I just want to take a second to go over them. So we use the sagebrush associations and persistent woodland data that Jeanne described for our base vegetation associations. But in the forest planning documents, I also included black brush and salt desert. So we included landfire biophysical settings to map out areas of black brush and salt desert. And we lumped them into a vegetation association called desert scrub. We relied heavily on additional data from the rangeland analysis platform. We used it as time series data from 1986 to 2023. And this was the basis for our vegetation change analysis. We wanted to stratify our analysis for burned and not burned areas. So we pulled down data from MTBS, monitoring trends in burn severity. We also masked out previously treated areas because a seeding, herbicide, or other management treatment would change the vegetation trajectory pretty significantly. So to do that, we used TWIG, Treatment and Wildfire Interagency Geodatabase, which is a pretty new database out there, but it's quite comprehensive and cool. And land treatment digital library data. And then we also use polygons from the forest, which is the only thing that would not be publicly available, but also not relevant outside of here. We pulled down data, climate data from PRISM and DAMET to get precip, climate, and water availability metrics to understand the potential drivers of differences among vegetation types. And to describe how wildfire risk was distributed on the Elko Front, we pulled down burn probability and flame lanes from these two data sets that are on the Forest Service Research Data Archive. We resampled all of these data sources from their original resolution, most of which are 30 meters, to a 2-hectare hexel, which became like our base sampling unit for all of this. So first I want to characterize the fire behavior on the landscape to set the scene for field treatments and current conditions. Here we're looking at the 2020 burn probability, where the map is showing us low burn probabilities in green and high in red. I've excluded areas of private lands, tribal, and state, as well as wilderness areas up on the mountain in the Forest Service areas, and those are mostly not sage. The highest burn probabilities are centered around the town of Elko and the communities of Spring Creek and Lamoille, which make up the WUI and really the bulk of that fire risk. And the plot on the right breaks out burn probability by vegetation association, where the x-axis is veg association and the y-axis is burn probability. Although the sage associations show strong differences in the median among one another, there is quite a high amount of variability across the landscape. So median burn probability is highest in Wyoming and Basin Big Sage, but it can be high as well in Mountain Big Sage, mixed sage, persistent woodlands. Using the time series data from RAP from 1986 to 2023, we did a trend analysis to understand how vegetation is changing across the whole Elko Front. I'm going to walk you through this plot for a second because it's quite a lot of data. We use beta generalized linear mixed effects models to model the functional group cover from RAP by vegetation association and burn history. The model gave us the slope of the change over time, and that's what the points are showing us. The error bars are the confidence intervals from those models. The x-axis is the slope of the trend, and the dotted line is at 0. So everything to the right of the dotted line is increasing, and everything to the left is decreasing. The vegetation associations are oriented by their general precip, temp, and elevation gradient. So desert scrub and Wyoming Basin Big Sage are the warmest, driest, lowest elevation, and Mountain Big Sage and persistent woodlands are the coolest, moistest, and highest elevation. In general, what we see here are increases in AFG cover in blue, decreases, AFG annual forb and grass cover. It's like the functional group that RAP pops out. PFG perennial forb and grass cover in red. We're seeing decreases in PFGs and decreases in bare ground cover in pink, really across the board. So every vegetation association is seeing these similar changes. The greatest rates of annual forb and grass increase were in Wyoming Basin Big Sage and mixed low sage, with moderate rates of increase in the moisture and cooler vegetation associations. The lowest rates of change were in desert scrub, really across the board. Perennial forb and grass cover was decreasing the most in Mountain Big Sage and mixed low sage. Shrub cover wasn't changing much, and tree cover was only increasing in the coolest and moistest vegetation types. Bare ground was decreasing, basically mirroring the increase in AFG cover. We can contrast the vegetation change between not burned areas with burned areas to get an idea of what happens to a given vegetation association when they burn. In this case, the rate of annual forb and grass cover change was always greater in burned than not burned areas, with the slopes being about 2.5 times steeper. And the greatest difference between the slope of annual forb and grass cover increase between burned and not burned was actually in Mountain Big Sage. Perennial forb and grass cover decreased in burned Wyoming Basin Big Sage, mixed low sage, and Mountain Big Sage, but it increased in black sage and persistent woodlands. Shrub cover declined in all burned vegetation types at similar rates. In a similar analysis that we did in Southwest drylands, we found similar patterns in functional group cover trends along a similar gradient going up a mountain, basically. In those Southwest drylands, we also found that between 1980 and 2019, both resilience and resistance had decreased by about 11%. And I think that we can assume that something similar is happening in the Great Basin shrublands and the Elko Front. To think about what that means for management, we can look at mountain big sage. We're seeing here that it's not necessarily as resistant to change or resilient post-disturbance as we may expect it to be, or it may have been about, even 20 years ago. And this is really the driving impetus for our approach in understanding how vegetation is changing to make sure that we're implementing the appropriate treatment and management actions for relevant vegetation changes and current community composition. I want to zoom in really quickly on tree cover changes over time because managing tree encroachment and infilling is key to meeting the objectives of reducing wildfire risk and promoting perennial herbaceous cover. This figure here shows us how tree cover is changing in not burned Wyoming basin big sage, mountain big sage, and persistent woodlands. The points indicate how the distribution among tree phases is changing over time. Yellow is not treed, brown is phase 1, green is phase 2, and blue is phase 3. What we see here is little change in Wyoming and basin tree cover over time. In general, most of the area is not treed, and it stays that way. There's a slight decline in not treed and a slight increase in phase 2. In mountain big sage, we see a steep decline in not treed, where mountain big sage starts out as basically not treed. And by 2023, about 30% of the vegetation association is phase 1 or 2, and sometimes phase 3, but mostly phase 1 and phase 2. We're seeing a decrease in untreed as phase 1 and phase 2 increases, indicating basically tree encroachment into previously untreed areas. In persistent woodlands, we see a decrease in not treed as phase 2 and phase 3 increases, so some expansion, but also some infilling. So the trend analysis gave us a good idea of coarser level changes occurring in the vegetation associations on the Elko Front. One thing that stood out to us from the raw data, and if you're a manager, you know this just from going out in the field, is that there's strong variation in functional type cover across the landscape, and different kind of trajectories have changed. Some areas are encroaching really rapidly. Some areas are having these booms in annual forb and grass cover. And I think that the variation, just looking at this map, in PJ, encroached shrublands, and persistent woodlands is a good example of that. So we want to zoom in and kind of get an idea of the variation occurring within vegetation associations. So to understand the variation of functional group cover change within vegetation types, we calculated the slope of the change from 1986 to 2023 of the functional groups, AFGs, PFGs, annual forbs and grasses, perennial forbs and grasses, shrubs, trees, and bare ground for each hexel in the Elko Front. And then we clustered those by their slopes into 3 distinct trajectories of change. So we see that across the dominant vegetation associations, every hexel kind of gets shaken out into these 3 categories that we describe as minimal change, annual forb and grass expansion, and tree encroachment or infilling. The greatest proportion of the landscape was actually characterized by minimal change, 76,000 hectares or 60% of BLM and Forest Service land on the Elko Front. In this figure here, we're looking at the distribution of the functional group cover trends in the minimal change cluster. So the y-axis are the Thielsen slopes of those hexels. In this cluster, the slopes are relatively close to 0. And between 1986 and 2023, the actual cover stayed within about 5% of its starting values. In general, these areas had low annual forb and grass cover to start with, less than about 4% median cover in 1986. The areas of minimal change were slightly cooler and moister and tended to be in those higher resilience classes, but in general, there wasn't a ton of differentiation in the biotic and abiotic variables in this cluster versus the annual forb and grass expansion cluster, especially for Wyoming and basin big sage. We can contrast the group with minimal change to this one with annual forb and grass expansion. This makes up about 28% of the Elko Front, or 36,000 hectares. And this is where we're seeing pretty alarming rates of change in AFG cover. So in the previous cluster that I showed, the one characterized by minimal change, in 2023, cheatgrass cover was about 9% in Wyoming basin, 5% in mountain, and 4% in persistent woodlands. In the areas of annual forb and grass expansion, AFG cover increased from 9% in 1986 to 24% in 2023 in Wyoming and basin big sage, 8 to 21% in mountain, and 8 to 22% in persistent woodlands. This was accompanied by a 5% decrease across the board in perennial forb and grass cover and an 8 to 11% decrease in bare ground. These areas had higher starting annual forb and grass cover to begin with. They were also warmer and drier and had higher heat load indexes. likely driven by aspect when compared to the same vegetation types in the other clusters. So we think about mountain big sage as being pretty resilient, but if you're a mountain big sage that's on a south-facing slope with a higher heat load index, it's going to change, and we see that here. And then this is our third cluster, the one of tree encroachment in the sages and infilling in the persistent woodlands. This makes up about 13% of the not-burned areas of the Elko Front, or 16,000 hectares. These areas are characteristic of increasing tree cover. With the increases in tree cover, we also see decreases in shrub cover, or decreases in perennial forbidden grasses, decreases in shrub cover, at least for Wyoming Basin and persistent woodlands, and we see that tree cover increased by about 7% to 14%. Perennial forbidden grass cover declines were pronounced in mountain big sage, and shrub cover declines were pronounced in Wyoming Basin big sage and persistent woodlands. Areas of tree encroachment into the big sages were about 6 times closer to persistent woodlands than areas with no tree cover, which might be from like a dispersal mechanism or like topography, and where they kind of co-occur on the mountain. The persistent woodlands with infilling had higher tree cover to begin with, so similar to what we saw in the annual forbidden grass expansion areas. So it's kind of just like a classic example of population dynamics and change over time. And then here is what that looks like mapped out across the landscape, broken out by vegetation association. So when we look at these clusters, we saw a little differentiation between minimal change and annual forbidden grass expansion. In this map, we can see the co-occurrence of that, especially in Wyoming and Basin big sage. The areas with AFG cover expansion had higher AFG cover to start with. So what we're seeing here isn't necessarily a recent change, and undoubtedly it's related to like long-term land use histories. But we're seeing more of a differentiation in the minimal change versus AFG expansion in mountain big sage, where higher elevations up the Ruby Mountains are mostly minimal change, and down below it's mostly AFG expansion. But again, a pretty good mixing of the two groups. Tree encroachment and infilling is hard to see because it is a very low proportion of the landscape, relatively speaking. So from the trend and cluster analyses, we understand how vegetation is changing and where it's changing. What's striking from this are the wide-scale AFG increases, the wide-scale PFG decreases, as well as bare ground decreases, especially occurring in those clusters where the changes are really concentrated, but it also highlights the widespread areas that are relatively stable. It's also interesting that existing cover and population dynamics play such a big role in the trajectories of change. And to us, this highlights the importance of opportunities for AFG and PFG management. So the treatment response groups provide treatment guidelines for woody fuels. But our work on the Elko Front highlights the importance of understory cover and condition. So to address the ongoing changes in perennial forbs and grasses, annual forbs and grasses, and tree cover, we built upon the existing treatment response groups in this figure here to address those understory changes and introduce opportunities for management and restoration. And I'm going to hand it back over to Jeanne, and she's going to describe that to us.
Thanks, Sophia. I am now going to attempt to share my screen. Can you all see that?
Yep, we see the slides on the side.
Great. How's that?
Looks great. Thank you.
Thank you. And thanks, Sophia. So let's dive right into the expanded treatment response groups for big sagebrush. We've simplified the treatment groups here, and for simplicity, I'm going to state them as being mountain, basin, and Wyoming big sagebrush that have relatively high to moderately high resilience and resistance. Our mountain, basin, and Wyoming big sagebrush group that has moderately low resilience and resistance, and then our basin and Wyoming big sagebrush types that are warm and dry and have low resilience and resistance. To really address the influence of the functional types on the treatments, we first added shrub cover as a criterion for determining the need for woody fuel treatments. Now, work that Ava Strand's lab has done showed that when shrub cover canopy is greater than about 15 to 20%, it becomes the primary factor driving both flame length and rate of spread. Below that 15 to 20%, herbaceous fuels are the primary driver. So if shrub cover is less than 15%, woody fuel treatments are really not needed. Now, second, we added perennial forbs and grasses as a criterion because numerous studies show that they largely determine recovery potentials as well as resistance to cheatgrass following both wildfires and our fuel treatments. And that's also what Sofia is showing, that we're starting to lose them. We used a threshold of 15% cover for determining if herbicide and seeding treatments were needed in conjunction with the fuel treatments. This was based on the literature review and then also on Sofia's work. This is indicated in the other vegetation management treatment column. Now, we place less emphasis on annual forbs and grasses than in many recent studies. While pre-fire or pre-treatment annual forbs and grasses often influence post-fire or post-treatment annual forbs and grasses, it is largely those perennials that determine the longer-term resistance to invaders. We considered the shrubs, perennial forbs and grasses, and relative R&R in assigning fuel treatments. We know that prescribed fire can be a severe treatment that places systems at risk of annual forbs and grasses where those perennial forbs and grasses are depleted and climate suitability to the annuals is high. As in our initial TRGs, we assign prescribed fire as a possibility only in high R&R areas with high perennial forbs and grasses. Mechanical treatments, we know, are less severe and can be used in lower R&R categories. And then anywhere perennial forbs and grasses are depleted and annual forbs and grasses are relatively high prior to treatment, it is necessary to consider herbicides, seeding, and transplants in conjunction with the treatments. Finally, it's been shown that treatments that disturb warm and dry Wyoming sage usually increase cheatgrass. As managers have already realized, and as we suggested earlier, fuel treatments are often the best treatment for protecting these at-risk areas. Because low, black, and mixed low sagebrush types are low productivity systems, we assigned no treatments to them. Now, if we move on to our pinyon and juniper treatment response groups, what we did here was to assign treatments for those pinyon and juniper encroached shrublands and persistent woodlands based on R&R, those perennial forbs and grasses, and the pinyon and juniper phase or successional stage. We again focused on phase 1 and 2 because of higher recovery potential and that greater operational feasibility. We allowed any shrub cover with the rationale that pinyon and juniper is the primary driver of woody fuels. We again used those perennial forbs and grasses as the primary determinant for determining if herbicide or seeding treatments were needed. We used the same rationale as for the big sagebrush treatments. Now, prescribed fire and cut and broadcast burn, as well as mechanical treatments, were allowed for areas with higher resilience and resistance. Mechanical treatments, mastication, cutting and removing the trees, or cutting and pile burning were restricted to areas with moderately low or greater R&R. Our rationale for treatments that remove the trees is that lop and scatter or cut and leave places the canopy fuels basically on the ground. Risk of canopy fire may be eliminated, but higher ground fuels can result in high severity fires, and we've seen this on several of our sage steppe sites. No treatment or selective thinning was used for warm and dry Wyoming and basin big sagebrush with low R&R. Again, where perennial forbs and grasses are depleted, herbicides, seeding, and transplants should be considered. We gave special consideration to our black low and mixed low types because these systems have low productivity and we don't want to impede their recovery. For phase 3, we gave a treatment of selective thinning to reduce crown fire risk and to improve understory over time. And for areas where we're seeing infilling into our persistent woodland, we suggested selective thinning, again to reduce crown fire, and then also to improve understory conditions. Now, had a bit of a delay there. Sorry about that. While our landscape scale products can be very useful in planning and prioritization, I think it's important to remember that field assessments are always going to be needed if we're going to understand the actual resilience and resistance in the field and select the appropriate treatments. A set of field guides based on our R&R concepts have been developed to provide the necessary information for really stepping down to the site. These were supported by our Great Basin Fire Science Exchange and are available through Jeanne and Corey. A key component are the score sheets that you can see on the right. These were developed for rapid site assessment. They allow a manager to go in and determine appropriate fuel treatments, if any, the need to seed, and also then post-treatment management. Now to wrap up, we know the Great Basin is changing. Prioritizing treatments based on an understanding of recovery potential that R&R can ensure effective use of resources and maximize benefits in terms of, going back to the beginning, reducing wildfire risk and improving vegetation. Sofia's work illustrates the need to monitor and assess changes in climate and vegetation. We can ask, where are shifts in climate decreasing resilience and resistance? Where are losses of key species occurring? Now, climate smart management is needed to help address the ongoing changes. To name just a few actions, adaptive grazing management that takes into account drought years and areas with declining perennial forbs and grasses, and then also restoration seeding of species that are adapted to both fire and climate warning. All of our spatial data are available on the Forest Service Research Data Archive, and our publications are available through Tree Search and the Great Basin Fire Exchange website. And with that, I think we're ready for questions.
Wonderful. Thank you so much, Jeanne and Sophia. That was great. So if you have questions, please type them into the chat. And or if you want to raise your hand, I can unmute you, and we can open it up for Q&A. So I have a question to start out. So those great tables that you showed, Jeanne, with what you look at, the cover, shrub cover, tree cover, the percentage, and then what treatment you recommend for each of the resistance and resilience categories. Which one of the publications, I was clicking through the publications to try to find them so I could let the audience know, where do you find those tables?
Well, those are brand new, Jeanne.
Oh, great. Okay.
And I can't start my video because it says it's disabled.
Oh, that is my fault. Okay,
No
hold on a
worries.
second.
Anyway, those are what we've recently developed through our Elko Front work, as well as our work on the high priority landscape in Pine Valley. And Sophia is going to be developing a manuscript soon that will make those available.
And this is my push to do it.
Thank you. Sorry about that, guys.
Yeah, no worries.
Great. All right, let me get to the chat now. Okay. All right. Okay, come on, there has to be some questions out there. And I allowed people to unmute themselves. Yeah, you're welcome to jump on and ask a question or type it in the chat.
So
I
I'll
think
ask
we've
a
overrun
question.
them.
No. I'm curious about the process, Jeanne and Sophia, in developing all of this with the managers. How many trips? How was it received? are you being hit up by other forests for something similar? I'm just curious about the process in general.
Well, I think there's been a different process for the Pine Valley high priority landscape than there really was for Elko. For Pine Valley, essentially, we started a large project down there, and one of the first things they asked for actually was that score sheet and that it be adapted to their specific conditions. So that's where we started down there. Then working with the forest over time, and we had several different field trips down there, as well as ongoing interactions via Teams, not Zoom, to kind of flesh out the questions and go forward. We ended up looking at vegetation change over time, creating essentially resilience and resistance indicators that were specific to the Southwest drylands we were working in, and then looking at that change again over time and starting to flesh out the criteria that you see here. In fact, some of these are in that Southwest dryland manuscript. And do you want to jump in on Elko, Sophia?
I mean, you were there for like, I kind of jumped in like halfway through it, I feel. But with the Elko Front, we did a field visit back in 2024 in the summer. And I feel like they're interested in the vegetation changes and assessing that. And I think what we've been working with them on is mostly adapting the rule set to come up with treatment prioritizations across the landscape. So how can we, where can we treat, in what way can we treat, and how can we maximize hitting all of their high value resources? And that's been working with Alan Ager and Michelle Day to use this software called Forces to come up with like a prioritization kind of scheme to do that.
So is there going to be follow-up? Sorry, I'm just going to keep going.
Yeah.
Will there be follow-up when they do a treatment that you've proposed, and looking at that and adapting, maybe change the table somewhat if you didn't get the result you were expecting, or what are the next steps and learning beyond this?
I think that's a great idea, and with a little more research funding, we would be happy to go out and follow up on those treatments. We will continue to work hopefully closely with the forest, with Aaron Hayden and folks out there to better understand how they're implementing treatments on the ground, and then also what the outcomes are.
That's great. Thank you. A question that's in the chat: after 20 plus years of working on sagebrush ecosystems, what were some of the most surprising or unexpected findings?
I think I wasn't prepared for how quickly these systems are changing in terms of the elevated temperatures decreasing our resilience and resistance, as well as seeing basically now on two high priority landscapes a pretty significant decline in our perennial grasses and forbs. So I think what it does, however, is point out which climate smart strategies we really need to be implementing, as well as we mentioned, paying more attention to monitoring and the changes we're actually seeing on the ground.
Thank you. Great talk. To what extent will prioritization take into account the climate projections to work toward developing communities resilient to persistent change?
That's an excellent question. When we developed our resilience and resistance indicators for the entire sagebrush biome, Daniel Schlepfer and John Bradford went in and did some climate modeling projections of how they're likely to change over time. And that was part of the reason we developed those R&R indicators to be climate sensitive, to be based on climate variables. And that information is already out in a 2025 paper, and we should have shared it with you all.
I just shared it in the link. It's that
Oh,
ESA
okay.
Journals link. Yeah.
Oh, okay, great. So that
Yeah.
gives an indication of how things are likely to change. And it also gives a couple of different formats of those R&R indicators, the categorical ones we talked about, but then also continuous ones that folks may find to be fairly useful. So there's that aspect. And I think the next thing we're going to do, and I see Jesse's online, that funding is coming through, and we're going to be developing new resilience and resistance indicators for the Great Basin. They're going to be more categorical, and there will be more categories, if you will. It'll be finer resolution that we're hoping will really help folks out. And then by working with the Great Basin Fire Science Exchange, we're also going to be putting these data layers up on the climate engine that is sponsored by DRI so that we can look not only at the various layers that we've already talked about and already developed, but then hopefully incorporate those resilience and resistance indicators and track how they're changing over time.
Thank you so much. And thanks for mentioning that, yeah, these map layers will be uploaded into Climate Engine in the coming months. So stay tuned for that. Have you been able to evaluate any locations where misapplied treatments, i.e. generic CWPP prescriptions, have accelerated loss of PFG communities?
For this analysis, we specifically excluded treated areas. It looked like Jeanne was going to pop in and say something. Sorry, I cut you off.
So go ahead.
Oh, no. And then I was just going to say, I think that when we went out on that field visit on the Elko Front, I think we haven't analyzed it, but I think we have an idea that that's probably has occurred in the past. I think just like based on looking at a site and going, okay, that happened. Mostly, I think Forrest would mind us like talking about it, but because like they were aware that it wasn't the best treatment maybe, but going into like phase 3, encroached shrublands and just mowing down all of the tree cover that was there. So there were no persistent or perennial forbs and grasses available to regenerate post woody fuel removal.
We haven't done a formal analysis, but I think that is a good idea. Through our Sage Step project, we've gotten a really good indication of the importance of those perennial forbs and grasses, especially in our lower resilience and resistance areas. So we do have that long-term data set, and I think it's providing some great information about ongoing vegetation change over almost 20 years of data now.
That's great. Thanks. Are other high priority landscapes requesting this mapping for their regions?
We have worked with various entities within the Forest Service in the past to help incorporate the resilience and resistance concepts. The only other high priority landscape we're thinking about working on, and actually we're beginning to, is the Sierra Front. That's a bit of a different situation. You know, we're really transitioning from our sagebrush systems into more pinyon and juniper encroachment into our shrublands, and then all the way up to our Jeffrey pine systems. So we'll be looking at that system in some detail in the near future to better understand the spatial dynamics and the changes occurring over time.
Great.
And I'm sure we'll come up with some pretty similar layers to what you've already seen.
Excellent. And someone wrote in the chat, asked where the score sheets were. And so I put the links to the Miller Chambers guides from 2014 and 2015, and that they're in the back, they're in the appendices. But were there, I know, I think there had been some attempts, maybe Jeremy Maestas was going to update them. So I don't know if you've done any updating of those score sheets, Jeanne, or if this is accurate, just the appendices in the back of those two pubs.
That's accurate. But
Okay.
in addition, we developed a scored sheet specific for those Pine Valley ecosystems as well.
Okay.
And those are kind of transitional between our Great Basin sagebrush ecosystems and those Southwest shrublands, where we start to pick up a larger diversity of shrubs.
Okay, great. So for those score sheets, that'll be in the Pine Valley publication that Corey put the link in the chat earlier.
Yes,
All right.
yes. We're happy to help adapt them, to people's specific needs as well. The
That's great.
basic concepts work well, and they're fairly readily adapted to specific conditions. And it is most helpful actually to work with the managers to determine the aspects that they're most interested in.
That's great. So yeah, attendees, if there's anyone who wants to adopt those score sheets or get more information, please reach out to Jeanne, or yes, I guess reach out to anyone on this call and we'll get you to Jeanne. Great. Okay, well, that looks like the last question in the chat. Yeah, any final thoughts from the presenters? Okay. Well, thank you so much, Jeanne and Sophia. This is really interesting, and looking forward to seeing these guides come out. I don't know if you can see, but lots of applause coming through. So for attendees, when the webinar closes, there'll be a 3-question survey. If you wouldn't mind taking it, it really helps us out. And we'll post the video sometime next week, and I'll reach back out when that's posted and let everyone know. So again, thanks, Jeanne and Sophia, for presenting this great research and applications, and thanks for all the great questions. And I believe that's a wrap.
Thank
Thanks for the
you.
opportunity. Thanks.
Yeah. All right. Have a great day, everybody.
Bye.
Bye-bye.